Greetings, scholars. Time for us to continue our Module 5 notes. We are picking up today with Lesson 5-2, Module 5, Lesson 2, Volume and Packing with Cubes. Went ahead and tried to get it started a little bit since yesterday's lesson took a lot longer than I meant it to. 5-1 took much more time than I had planned. So we'll try to make this one a little quicker if I can. We do have some vocabulary we need to look at, including a word from yesterday's vocabulary list, solid. So, air conditioner kicking on. Solid is a three-dimensional, I'm sure you remember this from yesterday, and if not, you can always check back in your notes, a three-dimensional figure. Three-dimensional means that it has length, it has width, and over here in the margin, it has height. Length, width, and height. Okay. So solid is just a three-dimensional figure. Now today we're going to break the three-dimensional figures down a little bit. I will mostly be referring to a cube since that's what we used in class, but I will show you some other three-dimensional figures as well next time I see you. We'll talk about some other solids. Okay. But for number 2, we're going to talk about the face of a solid. I used this term a few times when I saw you in class, hopefully, and I know I used it on the last video. Face is essentially just the side. Okay? The face is the flat side or sides, because again, they're usually going to have more than one. Okay? The flat sides of a solid. The flat sides of a three-dimensional figure. The flat sides of a solid usually, now I want to make sure this, I emphasize, not always the case, but usually the face is going to be a two-dimensional, 2D shape that you know already. Usually a 2D shape you already know. Okay? Usually a 2D shape you already know. It is flat. It is flat. Okay? It's two-dimensional. So 3D shapes are built from two-dimensional sides. Those two-dimensional sides are built from one-dimensional parts. How does that work? If we're talking about an edge, this is the line segment, And again, we want to be careful. Not a line. Remember, a line goes on in two directions forever. We don't want that whole thing. We just want a piece of it. The line segment where two faces meet. The line segment where two faces meet. This is the edge. This is the edge. Now in a cube, you can picture this. Go ahead and use my Lego brick right here. Okay. This is a three-dimensional solid. We'll just kind of ignore the studs on top right now. But this is a three-dimensional solid. It has faces, right? It has these flat two-dimensional sides. Please pretend this is flat on top too. Now where the faces meet, right here, and then this face right here, can you see that line segment? Can you see that line segment? That's the edge. Okay, that's the part that if you kind of run your finger on, you can feel it feels a little sharp almost. Okay, that would be the edge. Now, if you saw me, I was kind of poking at a part that's even sharper. Our 3D solid, made from two-dimensional shapes that are stuck together, which meet at a one-dimensional line segment also includes a number of one-dimensional aspects. We call each of those a vertex. Vertex. Vertex is the fancy math word for a corner. It's a corner. But using our vocabulary from before, you want to think of it as the point. The point. Can you see how we're going back to all that stuff from yesterday? I promised you there was a point. The point where two or more, it's a little different with a vertex, you can have more, two or more edges meet. The point where two or more edges meet. So we have our 3D figure made up of 2D shapes which meet on one-dimensional line segments, which those line segments themselves converge, they meet at a one-dimensional point at a vertex. Geometry is cool. Now, I keep showing this Lego brick. I'm going to get a different example in a minute. Some of this stuff may be a little tricky to visualize. So mathematicians use a tool, and you will use a tool, because you're mathematicians, called a net. Now, it's not like a butterfly net. It's not the kind that you're using to catch things. This net is a two-dimensional pattern. Two-dimensional pattern. That means I can print it on a piece of paper. It means you can draw it on a piece of paper. A two-dimensional pattern made of 2D shapes. Made of 2D shapes that can be folded. Yeah, this one's getting a little long. A two-dimensional pattern made of 2D shapes that can be folded to model a solid. Okay. A two-dimensional pattern made of 2D shapes that can be folded to model a solid. Now we're going to try something a little bit different, a little unusual for one of these videos, so if it's a little weird, forgive me. Are you ready? First of all, I'm going to turn your entire world upside down. And then we're going to zoom back this way. Oh no, we're moving down the desk. This is over where Mr. Landre is sitting. Uh-oh. Yep, here's Mr. Landre. Okay. But I'm holding this cube, and this is why I wanted to do this. Because you can see this cube, this is a three-dimensional solid, a three-dimensional figure. But this is a fun one. So if I pop the bottom off, first of all, you can see it's a square, just like all the rest of these faces are squares. They meet at edges. Okay. And the edges, here's an edge, here's an edge, here's an edge. They all meet at a point. Sorry, I'm a little more centered. Okay. But the real reason I wanted to show you this, I'm going to back up a little bit. There we go. Actually, move the camera a little bit. The real reason I wanted to show you this is because if I reach inside, pull the cube out, some of you probably see where this is going. I can take this and I can flatten it out. And it becomes a net. This is a net. This is a net. It's a two-dimensional pattern. See, it's made up completely of squares because every face on the cube is a square. I can use this pattern to then build a three-dimensional figure. If you've ever done papercraft or downloaded any of those kinds of things on the internet before, then you've seen this, you've done this. But if you haven't, it's pretty cool the first time you recognize that all these three-dimensional shapes can be pulled apart and broken down into a flat pattern. Okay. So let's go ahead, put that back in its box. Don't want it to get lost. Snap the face back on the bottom. Okay. We'll do some more of those in class. Let's get back to the notes, which are still upside down, so prepare yourself. There we go. I was going to edit that out, but it's probably more fun just to have it sitting there. Okay. We've got about 3 or 4 more minutes I want to try to wrap up, because again, I know yesterday's notes were very long. So, we'll do one example. We're going to explore a little bit. Okay, we're going to explore a little bit. We are going to draw a net together. Now, this net is not going to be perfect. Please don't feel like you have to draw the world's greatest net. Don't worry about rulers and nonsense. Just follow along with me. Okay. You just saw an example. You can always back up the video and see it again, but we're going to create it together. Go ahead and skip down 1, 2, bunch of lines. We're just going to go somewhere in the middle right about here. And I am going to draw a rectangle. Okay. Now we can think of this rectangle, you see it took 2 lines, we can think of this rectangle as our base. I'm going to shade it in a little bit. Obviously you don't always have to shade in a net, but just to kind of make sure we're focusing on this one. Alright, my lines are getting crooked, but whatever, good enough. Here's our base. Now yesterday we talked about how you can build up from a base. The way we show that with a net, I'm going to draw out about that far. I'm going to draw out about that far. They should be about the same. And I'm going to do the same thing here and here. Now hopefully you can imagine, please don't cut your notes up, but if you cut this out, you could fold this up and in, 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 and you would end up with some walls. Pretty cool. But not a complete net yet. We have the base, we have that bottom, we have the walls, we have the sides, we have the faces, but there would be no top on the box. So I need to look at this piece right here and basically repeat it. Now I could attach it honestly anywhere. I could put it down here, I could put it up here. I am going to put it up here just so that we're using the space, because I skipped probably a few more lines than I needed to. Okay. And now this, I'll shade this one in too, because this is identical to the base below, or it should be. Please pretend with me. Okay. If I were to cut this out and fold it, that would make a rectangular prism. You can kind of picture it, make a pretty squat little box. This would be about the same as something like this. Okay. Draw a rectangle there. We'll draw the same rectangle up and back a little bit. Okay, not exactly the same, but close. Connect the corners. And then if you can imagine this top was solid, just erase those lines, erase that line and that line. We have a box that looks like that. Okay. I'll leave the side faces. I'll leave the side faces blank, but I'll go ahead and shade in the top so that hopefully you can see that. Now, I know we've got a lot of space left on the paper. Feel free to experiment and draw some other nets if you'd like. I didn't want to try to draw one that was too big, because if it goes off the page it gets really irritating. We'll be doing more of this with graph paper, which makes it a lot easier. You know I love graph paper. Alright folks, we'll go ahead and stop for today. Thank you for following along. If you have any questions, please make sure you bring them to class, and I will see you next time. There we go.